Target: given a function in symbolic form containing either an exponential or logarithmic term, determine a symbolic expression for the inverse of the function. So again, when we're dealing with logarithmic equations, I always have this definition out. Here's our function. F of x equals 8 plus 9 times log base 2 of the difference of 4x minus 7. So the first thing we always do is rewrite the f of x as y. And then I want to get this log expression by itself so I can utilize this definition up here. Because eventually I want to solve for x. So I need to subtract 8 from both sides and then divide by 9. And I'm left with this expression. And so now we can go, when we have log base 2 of something equals something, right here, log base b of y equals x implies the base raised to the power of that thing on the outside equals the thing inside the log. So 2 raised to this piece equals that piece. So 2 raised to y minus 8 divided by 9 equals 4x minus 7. And I put the x on the left side. It doesn't matter. I switched sides of my equation here. But I know I'm solving for x. I like having the things I want to solve for on the left side. So now I'm going to add 7 to both sides and then divide by 4. And therefore we have the inverse function. And it is 2 raised to this power here plus 7 all divided by 4. Let's look at a function with an exponential in it. So we have f of x equals 3 times 4 raised to the x minus 5. So we're finding the inverse of this function. The first thing we do is rewrite f of x as y. And now I need to solve for x. So to solve for x, I need to get 4 raised to the x by itself. So I need to add 5 to both sides, then divide by 3. So 4 raised to the x equals y plus 5 divided by 3. And now anytime you have a variable in the exponent, you need to take do the log of both sides to get that thing out of the exponent. And the easiest thing to do here is take log base 4, because watch what happens. Log base 4 of 4 raised to the x, that thing is simply x. And then log base 4 this side. Anything we do to one side of an equation, we have to do it to the other to maintain our equality. And note here that you could have used a natural log or log base 10 or any log that you wanted to. I chose log base 4 because I like what happens right here. That just turns to x, and we have a nice little expression here for the inverse function. F inverse of y equals log base 4 of this quotient here. And that will end this video lesson for this learning target. Thank you.